All right, the Indiana Jones problem. The basic thing that you have to understand here as you read through this information is that the mass of the sand and the mass of the gold statue have to be the same. This is how you would avoid triggering the mechanism, is keeping the masses the same. So let's just kind of notate that we're going to say, hey, the mass of the gold has to be equal to the mass of the sand. Well, remember we had this little flux capacitor chart that we made, and if you look at mass, we could see that mass is equal to density times volume. So what I'm going to do instead is I'm going to say the density of gold times the volume of gold has to equal the density of sand times the volume of sand. And if you look down here, we're actually asking for the volume of sand. So that's just that. So we just need to solve for the volume of sand, which is no big deal. Just divide both sides by the density of sand. And we have the volume of sand equals the density of gold times the volume of gold divided by the density of sand. Well, they give us these numbers. We actually have this information, right? The density of sand is right here. And the density of gold is right here. But the volume of gold, we have to calculate that based on these dimensions they give us, because they tell us it's a cylinder and it has a height of 25 and a radius of 6. So we're actually going to have to calculate the volume of gold. So let's figure out what the volume of gold is. So the volume of gold, if it's a cylinder, is pi r squared times the height. Well, we know the height and we know the radius, so it's pi times the radius squared times the height. Well, let's kind of work with this. 6 squared is 36. 36 times 25 is 900 pi. So 900 pi. Okay, remember, this is really the volume of gold, right? So I'm just going to plug everything in now. So we know that the density of gold is 20, and we can put our dimensions, cubic centimeters, grams per cubic centimeter. And we know that the volume of gold is 900 pi. And if it's volume, that's going to be in cubic centimeters. And then that's all over the density of sand, which they told me is 2.5 grams per cubic centimeter. Well, this grams per cubic centimeter cancels out with that grams per cubic centimeter. And so we just have 20 times 900 divided by 2.5. We're going to not even mess with this pi symbol. We're just going to leave it out because it actually says in terms of pi, what is the volume? So I'm not even going to multiply the pi. I'm just going to do 20 times 900 and then divide by 2.5. So if you do all that, 900 times 20 divided by 2.5 is 7,200. Remember, we didn't do anything with the pi symbol, so I'm just going to leave the pi symbol there. Cubic centimeters. Boom. That must be our answer. That must be the volume of sand. That's it. So remember, I started by making the masses equal, and then I knew that mass is equal to density times volume. So I did density of gold times volume of gold equals density of sand times volume of sand. From there, it's just plugging in the values that they give you. All right. See you guys in the next video.